This is chapter 4. It's about polynomials and polynomial functions. And so we're going to go through 3 sections here. There'll eventually be more. But the first one is Introduction to Polynomials and Polynomial Functions. Then we do some of the operations on polynomials, like multiplication. And then we do introduction to functions and how they relate to polynomials. In other words, it's something that looks somewhat familiar because we talked about functions already. So the objectives for the first section of 4.1 is to identify terms, and there are lots of them, degrees and coefficients in polynomials, and the types of polynomials, and how to arrange polynomials in ascending and descending order. We're going to learn how to evaluate the polynomial function for given inputs. Then we talk about like terms and collecting like terms in a polynomial, and then how to add polynomials, and also how to subtract polynomials. So these are the objectives here for section 4.1. And I think you'll find polynomials are very easy to work with. In a way, you can think of them almost like working with integers. And for example, when you add and subtract integers, you will always get another integer. And when you multiply an integer, you will also get another integer. And the same is true for polynomials. When you add or subtract polynomials, you get another polynomial. And when you multiply polynomials, you will get another polynomial also. But a lot of right now would be about definitions and notation. And so that's the first thing we're going to talk about here. The first of many vocabulary words is that of a monomial. And a monomial is a constant or constant times some variable or variables raised to powers that are non-negative integers. So the non-negative powers, that's really important. You will see later on. So here are examples of monomials: 0, minus 3, z, 8x, minus 7y squared, 4a squared b to the third power, 1.3 p to the fourth, q to the fifth, r to the third. So the last one was 1.3 p to the fourth, q to the fifth, r to the seventh power. So these are examples of monomials. Next, we have the definition of a polynomial. And so a polynomial is a monomial or a combination of sums and or differences of monomials. So here we see it, for example, here's a monomial, 5x squared. Here's a polynomial, it has more than one term, 2y squared plus 5y minus 3, so that is a polynomial. Or 5a to the fourth minus 3a squared plus 1/4 a minus 4. So these are examples of polynomials in one variable. Then there are expressions like the following. They're called polynomials in several variables, like 15x to the third y squared, a minus b, 1/2 xy squared z minus 4x to the third z, plus y to the third plus 9. So we have 3 polynomials in more than one variable, or several variables. Here's a monomial, here's another polynomial, and here's another polynomial. And then here are some algebraic expressions that are not polynomials. For instance, the first one here, y squared minus 3 divided by y squared to the fourth power, that is a ratio, a fraction of 2 polynomials, so that is not a polynomial. And the next one, 8x to the fourth minus 2x to the third plus 1 divided by x, is not a polynomial either, because we have x in the denominator, and that would mean x to the minus 1. So in other words, the exponent is not a non-negative integer, it is a negative integer, minus 1. And then again here for the third example, we are talking about a fraction of two polynomials, a monomial divided by a polynomial, 2xy divided by x to the third minus y to the third. So these are non-polynomial expressions. Now again, some more definitions. The terms of a polynomial are separated by plus signs. The polynomial 5x to the third y minus 7xy squared minus y to the third plus 2 has four terms. 5x to the third y minus 7xy squared, then minus y to the third, and then 2. Now here's a question some people ask when it talks about the definition. The terms of a polynomial are separated by plus signs, because you obviously see some minus signs here. 5y to the third, x to the third y minus 7xy squared minus y to the third plus 2. Well, you can still say they're separated by a plus sign or by plus signs. And that's because the way subtraction is defined, and that is that, for example, for any two numbers, a minus b, that is defined as a plus the opposite of b, or minus b. So in other words, we could rewrite the polynomials that are separated by the minus signs. We could rewrite them, for example, as 5x to the third y, 5x to the third y, plus minus 7x y to the third, plus minus y to the third, plus 2. So now all the terms are separated by a plus sign. Now again, typically we would write it this way, but that's just to explain why they say they're separated by plus signs. So here we've done it, but we've rewritten it. But usually that is not necessary. Here's some other definitions of terms. A very important definition would be that of a coefficient. And the coefficient of a term is the number that multiplies a variable. So for these terms, 5 is a coefficient of x to the third y. And minus 7 is a coefficient of the next term. Minus 7xy squared. And remember that it really means 7 or minus 7 times xy to the third, or 5 times x to the third y. So it's implied multiplication. So we can say that the coefficient is a number that multiplies the variables, or the variable. Here, this one is a little bit tricky, but think of it as a minus 1. Minus 1 times y to the third. So minus 1 is the coefficient. And then the constant term, 2 is called the constant term, that would also be considered a coefficient of the polynomial. But it's a constant term. It doesn't change. It's not a variable term. And then some more important definitions. And that is the degree of a term is the sum of the exponents of the variables, if there are variables. For example, the degree of the term 9x to the fifth is 5, because the exponent is 5. Now the degree of the term 0.6 a squared b to the 7, we add the exponents. 2 plus 7 is 9, so the degree of this term is 9. So be sure you remember what the degree of a term means. Before we move on for the next concepts, it may be necessary for some of you to review the explanation on exponents. And then the beginning of the book, among the first 29 pages that I had recommended in the beginning, that you really study the first 29 pages. And I know the beginning of the semester was a little bit unusual since we're all online and all of that. But if you haven't done it yet, make sure you put that on your calendar to go through the first 29 pages. Specifically, we need page 13 and page 26 that deals with exponents, like what it means to raise a number to the 0 power. That would really be an important concept to understand, like that a to the 0 power is equal to 1 for any real number a other than 0. And also the basic rules for exponents that are discussed on page 26. So it would be critical for understanding what's happening here in this chapter to know the rules for exponents. Okay, so please do me a favor and go back there because, again, most of, or many of you will need that information. So to begin with, when we talk about the degree of non-zero constant terms such as 2, well, the degree of a non-zero constant term such as 2 is 0, because we can express 2 as 2 times x to the 0, and we know that x to the 0 is equal to 1. Any real number raised to the 0 power is 1, unless x is equal to 0. Then we cannot do it. So because we can express 0 as 0 times x to the 5th equals 0 times x to the 12th, and so on, using any exponent we wish, the term 0 has no degree. Okay, so the constant term has no degree. So the next step is to define the degree of a polynomial, and it's the same as the degree of the term that has the highest degree. For example, the degree of this polynomial 4 minus x to the 3rd plus 5x squared minus x to the 6th is 6, because the term with the highest degree is x to the 6th, or minus x to the 6th, and the exponent is 6. So that determines the degree of the polynomial, for this polynomial. Then we talk about the leading term of a polynomial, and that is a term of the highest degree. And then its coefficient is called the leading coefficient. For example, when we look at this polynomial 9x squared minus 5x to the 3rd plus x minus 10, the leading coefficient is minus 5x to the 3rd, because it's a term with the highest degree. And so the leading coefficient is minus 5. Remember what the coefficient is. That's the number that multiplies the variable or the variables. And let's put this knowledge to work here. So example 1, identify the terms and the leading terms. So the terms are minus 92 x to the 5th minus 8x to the 4th, x to the 2nd power, or x squared, and 5. So these are the terms. And the leading term is the one with the highest degree, so there's minus 92x to the 5th. That is the leading term. Similarly, here we're supposed to identify the coefficient of each term and the leading coefficient also. So the coefficients are 5 for the first term, so the leading coefficient is 5. Here the coefficient is negative 4. For next term it's minus 2. For this one, even though there's not a number, there's an implied 1, so it would be 1. And then for this term, the leading coefficient, the coefficient would be minus 1. And then simply the constant term would be negative 5. And the leading coefficient would be the coefficient of this term with the highest degree, and so the leading coefficient would be 5. The next exercise asks us to do several things. Identify the terms, the degree of each term, and the degree of the polynomial. Then identify the leading term, the leading coefficient, and the constant term. So for the A part, the terms are 6x squared minus 5x to the third, 2x, and minus 7. These are the terms. The degree of each term, here we have degree 2, degree 3, degree 1 is an implied exponent of 1, and remember the degree of the constant term is 0. And the degree of the polynomial, we look for the degree of the highest degree of the term, and so it would be this one here, that's x to the third power. So the degree of the polynomial, degree of the polynomial, would be 3. And the leading term is a term with the highest degree, so it's minus 5x to the third, so leading term the minus 5x to the third power. The leading coefficient, would be minus 5, and the constant term, of course, is constant term is minus 7. So as you can see, a lot of the words we learned just a few minutes ago are now showing up in the problem here. So knowing your vocabulary is really critical for for this section, obviously, and all subsequent sections, because they will make use of this terminology. So please learn your vocabulary for this chapter in particular, because there are a lot of new words, words that are new to a lot of people. So let's do the same thing for the B part. So the terms are simply the monomials, and so that would be 2y minus 4 minus 5x 9x squared y to the third z squared, and 5x y squared. Now the degree of each term, so it's pretty easy here. So for the first term, the degree is 1, y to the first power 1. And then here's a constant term, and remember the degree of the constant term is 0. And the degree of minus 5x would be x to the first power, or 1. Now when we have several variables, we add the exponents. So 2 plus 3 is 5, plus 2 is 7. So this term has degree 7. Similarly, here we add the exponent. The implied exponent of 1 plus 2 is equal to 3. the degree of the polynomial is the highest degree of one of the monomials, and that would be 7. So that would be the highest degree that's from this term. So the degree of the polynomial is 7, the greatest number here. And the leading term is the one with the highest degree, so it would be 9x squared y to the third, 9x squared y to the third z squared. And then the leading coefficient would be 9. Yeah, the coefficient of the leading term is the leading coefficient, so that is equal to 9. And the constant term, as we saw, was -4. So you can see it's not very difficult, but you have to remember the definition of all the you have to remember all the terminology and what the words mean. Here are some additional definitions on how we classify polynomials. There's a monomial, that means it's one term, and here are examples of monomials: 4 minus 3p minus 7a squared b to the third, 0, x by z, so those are monomials. And binomials, it means there are two terms, like 2x plus 7, a squared minus 3b, 5x to the third plus 8x. And then trinomials, that means there are three terms, x squared minus 7x plus 12, 4a squared plus 2ab plus b squared. So these are examples of monomials, binomials, and trinomials. Now, what if a polynomial has more than three terms? Well, there's not really a special name. It's just generally called a polynomial if you have like one with 4 or 5 or more terms. So only the first three, the one with one term or two terms or three terms, have special names: monomial, binomial, or trinomial. And it's really pretty easy to classify these types of polynomials, and that's what the next exercise is about. Identify the monomials, the binomials, and the trinomials when you look at these presentations here. So A is, obviously a binomial. There are two terms, so it's a binomial. And here we have three terms. That's a trinomial. And that has only one term. That's a monomial. One term. D is a monomial also. Monomial. And that's also a monomial. It's only one term. And here we have two terms, so it's a binomial. Here we have 1, 2, 3 terms, so it's a trinomial. And then the last one has two terms, so it's a binomial. Then there's a matter of arranging polynomials in ascending or descending order. And ascending order means from left to right, the powers of the variable increase. So to arrange 5a in ascending order, we begin with 10x. There has only one exponent, so exponent of 1 rather, 10x. And then would be minus 6x squared, minus 6x squared, or 6x to the second power. Then we have 7x to the third power, or 7x cubed. And then we have minus x to the fourth. So you can see that the powers of the variable increase from left to right. That's the ascending order. And then when we have a polynomial to arrange in descending order, it's the other way around. We start with the highest power first, and so in this case, so it would be x to the fourth, so minus x to the fourth. And then we have 7x to the third, plus 7x to the third, and there's a term is x squared, so minus 6x squared, and then we have 10x plus 10x, and we have the constant term of 5 plus 5. So this polynomial is now arranged in descending order. In 6a, we're looking at a polynomial that is more than one variable, but we are told to arrange it in ascending order and ascending powers of y. So with the y to the second power, y to the third, and this constant term. So we begin with a constant term, minus 5, and then here's y to the first power, so we have plus 5 x to the fourth y, and remember we only focus on y, ascending powers of y, and then there's a y squared, so minus 3y squared, and there's a y to the third, so plus 3x squared y to the third. So again, it's about the ascending powers of y. So I'm going to emphasize a little bit more here. And then the last one would be arrange in descending powers of y. So here we're starting with the highest power of y, and that would be y to the third. Again, it's all about the variable y. So it would be this term here, 3x squared y to the third power. And then we're looking for a term with y to the second power, and that's here, minus 3y to the second power. And then we have y to the first power, or y, so plus 5x to the fourth y. And then we have the constant term, minus 5. So in one case, you have the polynomial arranged in ascending powers of y, and here you have the polynomial in descending powers of y. And it's typically more common to arrange polynomials in descending powers of a variable that's specified, or if there's only one variable, it's pretty obvious. Like here, that's the descending order of the variable. Next, we're talking about evaluating polynomial functions. Now, we've talked about functions before, and we had function notation that may have looked, for example, like f of x is equal to, let's say, 3x plus 2. And when we replace x with a number, like, let's say, for x equals 3, well, let's say 4, then we write this as f of 4. And what it really means, in this expression, we replace x with the number 4. So that means we multiply 3 times 4, because we are told that x is replaced with 4 now, plus 2. So that's 3 times 4 is 12, plus 2 equals 14. So in other words, f of 4, the function evaluated at x equals 4, equals 14. Okay? So that was a very simple concept, and I'm sure most of you still remember that. So now when we talk about polynomial function, we just talk about a function that has perhaps more than one term that has a value of x associated with it. So here's a polynomial function, like p of x, p for a polynomial, or could be any variable, and I mean it could be any letter. But here's an example, 5x to the 7th plus 3x to the 5th minus 4x squared minus 5. So the algebraic expression is used to describe the function, and that's a polynomial in this case. So to find the outputs of a polynomial function for a given input, we substitute the input for each occurrence of the variable. So for example, if we say, what is p of 4? P of 4 means we replace every x with the number 4. And I won't work it out, but it would mean 5 times 4 to the 7th power plus 3 times 4 to the 5th power, etc. So we place, well, minus 4 times 4 to the 2nd power minus 5. And then we need to evaluate what 4 to the 7th power is, etc., and add up all the terms. And they'll give us the answer to P of 4 equals whatever that number is. So you can work that out. That's a little exercise for yourself. But that's a basic idea. And so let's just look at one that's a little bit easier. And so here we look at the for the polynomial function p of x equals x squared minus 2x plus 5. We're supposed to find p of 0, p of 4, and p of minus 2. Now, p of 0 doesn't mean the polynomial is 0. It simply means we replace every x with the number 0. So let's do that. So p of 0 means, remember, we replace x with 0 now. So 0 squared minus 2 times 0 plus 5. And so 0 squared, of course, is 0, and minus 2 times 0 is 0. So then we only have 5. So p of 0 equals 5. Then p of 4, again, that means we replace every x with a number 4. P of 4 means 4 to the 2nd power minus 2 times 4 plus 5. And of course, 4 to the 2nd power is 16. Minus 2 times 4 is minus 8. Plus 5 equals 13. And p of minus 2, now you have to be very, very careful what happens to with the minus sign. So it means minus 2 raised to the 2nd power minus 2 times minus 2 plus 5. Now minus 2 to the 2nd power means minus 2 times minus 2, which is equal to positive 4. And minus 2 times minus 2 is another positive 4 plus 5. That's equal to 13. Again, you have to be very careful that you use parentheses here, because minus, just as an explanation in general, minus 2 to the 2nd power is equal to minus 6, it's minus 4, but minus 2 to the 2nd power is equal to positive 4. Remember that. So it's really important that we use parentheses when we replace a variable with a number, and take special care when it's a negative number. You really, really want to use parentheses. Otherwise, things can really go wrong. So you may want to remember this little explanation here. The following is a graph of a function that shows the concentration of an antibiotic in the bloodstream measured in micrograms per milliliter T hours after injection. So you can see that the concentration in the bloodstream rises and then has a maximum, then it falls. And so the question is, how do we use that? And so here in veterinary medicine, and so here's a function and a graph. And so we are supposed to evaluate this function here, c of t, when t equals 3, after 3 hours, in other words. So what it means is that in this expression here, for the concentration, we replace every t with the number 3. So c, the concentration after t equals 3 hours, equals minus 0.005 times 3 to the 4th power plus 0.003 times 3 to the 3rd power plus 0.35 times t to the 2nd power. So now we replace t with 3 again, so 3 to the 2nd power plus 0.5 times 3, and when we multiply that out, we get 4.326 micrograms per milliliter. So that would be the concentration after 3 hours. And so that would be the A part, evaluate C of 3, C when t equals 3. And so I just want you to understand how that works. And then it says use only the graph at left to estimate C of 9. Well, C of 9 then means after 9 hours. So here's 9. And so the vertical line meets the curve here. And we go over to the left. And that says 2. So then from the graph, C of 9 means 2 micrograms per milliliter. So that's how you can use a graph or a function itself expressed this way here. Bring it down, you can see it. So we can use it to evaluate it directly. Of course, we can also evaluate it for C of 9 directly, but the graph is a pretty good indication. And you can also see that verifying that t of 3, in other words, when t is equal to 3, it's a little bit above 4, so that makes sense that the answer was 4.326 micrograms per milliliter. So a very simple application, and again, it's fairly common to have polynomials graphed and then draw certain conclusions from the graph and evaluate that way. Next, we're going to learn how to add polynomials, and the prerequisite for adding polynomials was actually discussed in the very front of the book on page 23, the famous 29 pages you're supposed to study, because it deals with combining like terms. So you can go back to page 23, but for saving time, we discuss it again. And so two terms, and they have the same variables, raised to the same powers, they are called like terms. We don't use similar terms here, but like terms. And they can be collected or combined using the distributive laws. So please go to page 23 and review that in case this seems strange or doesn't make sense to you. But on page 23, again, it's explained in great detail. And so I will suggest that you go back to that page and study it so that you understand it. This is absolutely critical for what we'll be doing in this chapter that you know how to add polynomials by combining like terms. Okay, so here's an example number 9, combine like terms. So we look at the expression 3y minus 4x plus 6xy squared minus 2xy squared. Well, clearly the first two terms have nothing in common. They are not like terms. Let's look at the next two terms. Well, they have the same variable, x and y, and x is raised to the first power in the first term, x is raised to the first power in the second term. So far, so good. And then we realize that y is raised to the second power and y is raised to the second power also. So these two terms are like terms, so we can combine them. So when we combine like terms, there would be, again, we leave 3y minus 4x alone because they cannot be combined. And then we simply subtract or add the coefficients. So the coefficient is 6 and the coefficient is minus 2. So plus, I'm going to be very explicit, 6 minus 2 xy squared. Or finally, our answer is 3y minus 4x plus 4 xy squared. So if this does not make sense to you, then please review it, and again go back to page 23 perhaps, until it makes sense, because it makes no sense to proceed unless you understood what happened here in this example. We'll do more examples for adding polynomials, of course, but the basic example is an excellent one here, so please study it until you have a clear understanding of what's involved here. So next one is a guided solution for combining polynomials or combining like terms. So we look at all the terms here, and we say 3xy to the third, and we say 2x to the third y, and the 5xy to the third, and minus 8x, and the 15, and 3xy squared, and a minus 6x squared y, and we have an 11x minus 8. So we look at the first one, 3xy to the third, and we scan this, and then we find that there's a 5xy to the third also. So 3xy to the third and 5xy to the third are like terms. And then there's a minus 3x squared y, and there's a minus 6x squared y. So 3x squared y and minus 6x squared y are like terms also. Again, it has nothing to do with the coefficients, the numbers that multiply the variables, but it has everything to do with the variables being the same and having been raised to the same powers. And then we can see that 8x minus 8x and 11x are like terms, x raised to the first power only. So what I always do in a case like that, I underline the terms I've already taken care of. So we have the 3xy to the third and the 5xy to the third, and then we had the minus 3x squared y and the minus 6x squared y, and then we have the minus 8x and the 11x, and then we have the constant terms 15 and minus 8. So 15 and minus 8 are like terms. So now what about the term 2x to the third y? Well, there's no term that's like that, so that we leave that alone. So now we combine by rearranging the terms this way, that like terms are placed together. So we have 2x to the third y plus 3xy to the third, and we have 5xy to the third and minus 3x squared y minus 6x squared y, and the 8x or minus 8x plus 11x, and 15 minus 8. So now we combine like terms. Again, there is only one of these, so we just leave that alone, and then we have the 3xy to the third. So when we add the coefficient 3 plus 5 xy to the third, we get 8xy to the third, and then minus 3x to the third x squared y minus 6 x squared y. So minus 3 minus 6 is minus 9. And then for the x's, we have minus 8x plus 11x. So minus 8 plus 11 is positive 3x. And then 15 minus 8 is 7. And so now we are done. That's the final answer. Now, subtracting polynomials works very much the same way, except for one important difference. So here we're looking at two polynomials. One is minus 5x squared plus 4, and minus this polynomial 2x squared plus 3x minus 1. Now, the fact that the second set of parentheses is preceded by a minus sign, of course, indicates subtraction. But what it means for the purposes of removing the parentheses, it means as if we multiply each term inside the parentheses by minus 1. So in other words, this then becomes minus 5x squared. We can just drop the parentheses here because it's preceded by a plus sign, plus 4. And now, so minus 1 times 2x squared would be minus 2x squared. And minus 1 times positive 3x, so it would be minus 3x. And a minus 1 times a minus 1 is a positive 1. Okay? So make sure you understand what happened here. In other words, we changed the signs of each of the terms inside the parentheses to the opposite because that set of parentheses was preceded by minus sign. So whenever you see that, simply change the sign of every term inside the parentheses. Every term, not just the first, but every term has to be changed to the opposite. And now we look around and we look for similar, for like terms. So first of all, we have minus 2x squared. Start with the highest power first, minus 2x squared. And then there's a minus 5x. And then there's a minus 3x. And then there's a 4. And there's a 1, plus 1. So there's no other x to the second power, so that's the only term, 2x minus 2x squared. And then we have minus 5x minus 3x. Well, minus 5 minus 3 is minus 8x, and 4 plus 1 is 5. So that is the result of subtracting one polynomial from the other. And again, you may want to go over this and make sure you understand every step along the way, from changing the signs of each term inside the parentheses and why that is so, and then, writing things next to each other that are like terms, and then combining the like terms. Again, some people can do without this step in between, but initially I really suggest you take that step so you have clarity about what you're doing. So now we have one more example of subtracting two polynomials. And so we have minus 3p squared plus 5p minus 4 minus 3p squared plus 5p minus 4 minus the next polynomial, minus 4p squared plus 11p minus 2. Now, when we remove the parentheses from the second polynomial, since it is preceded by minus sign, remember we need to change each of the signs of the terms inside the parentheses to the opposite. So in other words, this now becomes a positive 4p squared. The positive 11p becomes a minus 11p. And the minus 2 becomes a positive 2. Again, that's because the second set of parentheses was preceded by minus sign. So when we remove the parentheses, each sign has to be changed to the opposite. Okay. So now we can write terms next to each other. They're like terms. So we have minus 3p squared. And we have 4p squared. And we have 5p. And we have minus 11p. And we have minus 4. And we have positive 2. As you can see, when you underline the terms that you've already accounted for, when you're combining them, it gives you a pretty good overview and make sure you don't miss any one of them. So now we have minus 3p squared plus 4p squared. So that would be 4 minus 3, which is 1. And 1p squared we simply write as p squared. We don't write 1p squared. It's understood as a 1 as a coefficient. And then 5p minus 11p. Well, 5 minus 11 is minus 6, minus 6p. And minus 4 plus 2 is simply minus 2, or negative 2. So that would be our final answer for combining these two polynomials, or subtracting these two polynomials. So again, when it comes to subtracting polynomials, you really have to be on your toes and watch for the minus signs. So here's one more, number 20, subtract. So again, for the first polynomial, we can simply drop the parentheses. So we get 2y to the 5th minus y to the 4th plus 3y to the 3rd minus y squared minus y minus 7. Now when it comes to the second set of parentheses, remember it's preceded by minus sign. So that means we need to change the sign of each one of the terms inside the parentheses. That means a minus y to the 5th becomes a positive y to the 5th. The plus 2y to the 4th becomes a minus 2y to the 4th. And the minus 2y to the 3rd becomes a positive 2y to the 3rd. So 2y to the 3rd. And the positive y squared becomes a minus y squared. And the minus y becomes a plus y. And the minus 4 becomes a positive 4. So now we're in a position to combine like terms. So again, let's take one intermediate step to put the like terms next to each other. So there's a 2y to the 5th. And there's another y to the 5th plus y to the 5th. And there's a minus y to the 4th. And there's a minus 2y to the 4th, minus 2y to the 4th. And there's a 3y to the 3rd, plus 3y to the 3rd. And there's another 2y to the 3rd, 2y to the 3rd. and then there's a minus y squared, another minus y squared, and there's a minus y, and there's a plus y, and there's a minus 7, and there's a positive 4. So now we're ready to combine like terms. And so 2y to the 5th plus 1y to the 5th, well, 2 plus 1 is 3y to the 5th. And minus 1y to the 4th minus 2y to the 4th means minus 3y to the 4th. So that takes care of these. And then 3y to the 3rd plus 2y to the 3rd. 3 plus 2 is 5. Y to the 3rd. And minus 1y squared minus 1y squared is minus 2y squared. And then minus y plus y is 0. So they cancel out. And minus 7 plus 4 is minus 3. So this then is our final answer to this particular problem here. And again, I would encourage you to do this on your own as well. The next exercise is also about subtracting two polynomials, except now we have fractions and decimals. So when we do this, again, when we look at the first polynomial, it's preceded by a plus sign, so we can remove the parentheses and not do anything except writing down the terms. So 3/2 y to the 3rd minus 1/2 y squared plus 0.3. Now for the next set of parentheses, remember it's preceded by a minus sign, so we need to change the sign of each one of the terms inside the parentheses. So this, of course, has an implied plus sign, so it becomes a minus. So minus 1/2 y to the 3rd. And this becomes a minus 1/2 y squared. This becomes a positive 4/3 y. And this becomes a minus 0.2. Okay? So now we can look for like terms and write them next to each other. And so there are two terms of y to the 3rd, so 3/2 y to the 3rd minus 1/2 y to the 3rd minus 1/2 y squared, another minus 1/2 y squared, and then we have a 4/3 y, and 0.03, or 0.3 rather, plus 0.3 minus 0.2. So now let's combine like terms, now that we have them next to each other. So let me just be a little bit more explicit here to help you better understand what's going on. So writing down the coefficients as 3/2 minus 1/2 y to the 3rd plus minus 1/2 minus 1/2 y to the 2nd power, and then we have 4/3 y, and 0.3 minus 0.2 is equal to 0.1. Now, inside the parentheses here, 3/2 minus 1/2 is 2/2, and 2 divided by 2 is equal to 1, so that's simply then y to the 3rd, 1y to the 3rd, combining 3/2 and minus 1/2. And then minus 1/2 minus 1/2 is minus 2/2, and minus 2/2 is equal to minus 1, or minus y to the second power. And then we have 4/3 y. There's only one of those with y. And then 0.01. So that would be our final answer. Again, I would recommend you try this yourself. Pencil and paper, and just work it out yourself. And I mean, you have the answer now in every step in between, but see if you can do it. And you ought to be able at this point to do this. It requires a lot of attention to detail, and it requires focus for a relatively long time. So it's best to do these kind of exercises when your mind is fresh, and you can again be focused for a while. But you can learn this. And this concludes section 4.1.